Welcome back, everybody, to another Theta Network update for November 22nd, 2023. It is Thanksgiving Eve, so he's ready to eat some turkey tomorrow. But before that happens, let's go over that Theta news. What's happening? Well, today we got the white paper to the Theta Edge Cloud. So yes, introducing Theta's Edge Cloud, the first hybrid cloud computing platform built on a fully distributed edge architecture designed to serve the compute needs of video, 3D rendering, AI, and more. The evolution of Theta's metachain and edge network coming in 2024. Now, I was wondering why we were getting some posts about the Google Cloud Tech presentation. There was a couple of retweets of it. It was this one right here that happened back in September. I was going, what's going on? Why are they retweeting this information? Well, now we know. It's because the white paper is here, and I thought we'd just do a read through of it, so that way we all have all the information here. I'm sure there's going to be a quick brief explanation from someone out there. Give us a nice little thread on Twitter or something. But I thought, let's just go over the full white paper to actually take a look at it, see what it's about, and just do that read through. So here we go. Let's dive right on in. So introducing the Theta Edge Cloud, the first hybrid cloud computing platform built on a fully distributed edge architecture. Theta Labs Inc., November 2023. So I have the introduction, market opportunities, Theta Edge Cloud overview, and more. So let's dive right into this read through. Let's start with the introduction. Theta Labs introduced the Theta Edge Network and Elite Edge nodes in the spring of 2021 with the launch of Mainnet 3.0 and with the launch of Theta's metachain in 2023. It became the leading decentralized Web3 video infrastructure. The vision was built out of a fully decentralized global edge network run by community members that would provide distributed computing storage and delivery capabilities for video encoding, transcoding, storage, and peer-to-peer delivery. Elite Edge nodes that stake T-Fuel for uptime mining earned additional T-Fuel for delivering higher performances with better hardware and software specs, with a number of partners launching subchains in 2023. Now, Edge nodes are now also compensated with partner TNT20 tokens for various video and AI tasks. The Theta Edge Network, with its more than 10,000 monthly active nodes, has become a key differentiator compared to other Layer 1 blockchains. The Theta Edge Cloud is the next generation technology that builds on the Theta Edge Network and the Theta metachain, significantly extending and generalizing its capabilities to become the first hybrid cloud computing platform that is built on a fully distributed edge architecture. Now, this journey began in April 2021 when Theta filed its patent for edge computing platform supported by smart contracts enabled blockchain network, which was granted in September of 2023. Now there's a photo showing the global distributed networks and nodes out there. Now let's go over market opportunity. Theta is introducing the first hybrid cloud edge computing platform that Theta can leverage thousands of edge CPUs, GPUs, nodes worldwide, in addition to a hosted cloud-based distributed architecture. This opportunity is motivated by three major industry trends. And what are they? Why is this popping up for me? Python. Don't know. But 2.1, increased video demand globally. So that's what this market opportunity is for. The amount of video content and related data continues to grow due to the increasing popularity of social media platforms and rising internet connectivity, particularly in less developed regions. Increasing video data traffic globally is also driven by demand for higher resolutions like 4K, 8K, and higher resolution videos. According to Fortune Business Insights, the global video streaming market size was valued at a USD value of $455.5 billion in 2022 and is projected to grow more than fourfold to over 1.9 trillion USD dollars by 2030. Now, this trend drives an increasing need for video encoding, transcoding, and delivery services, as well as global visualization and 3D rendering services for various industries, including manufacturing, healthcare, construction, education, and real estate sectors. Now, that's just the video on demand. Also, we have 2.2, adoption of AI across industries and applications. Now, AI is huge, and this is being adopted everywhere. But the market for artificial intelligence is expected to grow over 10x in the next decade, driven by adoption of AI applications across verticals from travel to manufacturing. Everything from supply chains, marketing, product making, research analysis, and more are fields that will adopt some aspect of AI within their business structures. Now, the release of ChatGPT in a generative AI market in 2022 was significant catalyst for the end users' adoption of AI and chatbots. Now, the overall AI market is estimated to grow from 142.3 billion US dollars in 2022 to over 1.85 trillion USD dollars by 2030, according to Statista. Now, this trend drives the need for CPU and particularly GPU compute resources to prototype, train, fine-tune, and serve AI models. Now, we're also going to be getting infrastructure and compute services. We got new bite-sized infrastructure compute services to support video, media, and general AI computational tasks that have become increasingly more important as computational data grows exponentially by 10 to 100x. For example, to fine-tune and train domain-specific large language models and generative text-to-image and particularly text-to-video AI now requires large amounts of data, which makes today's centralized systems cost-prohibitive. The ability to paginate or distribute the workload of a vector database, for example, that stores data in multi-dimensional spaces with each dimension corresponding to a specific feature or attribute, is groundbreaking. Now, the vector database are ideal for similarity search applications like natural language processing, computer vision, and recommendation systems. They complement generative AI models well and provide an external knowledge base for generative AI chatbots to ensure information's accuracy. Now let's go over the Theta Edge Cloud overview, the product's vision. Theta's product vision for 2024 to 2025 is to deliver a fully distributed hybrid cloud edge computing platform that caters to diverse needs of a wide range of users. This platform will be designed to meet the demands of global 1,000 corporations seeking scalability and performance and the flexibility for higher growth, small and medium businesses, researchers and developers at 3 to 5 times the cost of savings. And for example, for a network of high-end NVIDIA 4090s on a per GPU hour cost basis, Theta's hybrid cloud edge computing network should be, 1/5 to 1/3 the cost compared to Microsoft Azure, AWS, or Google Cloud. Nice. Now, large enterprises, the SMBs and individuals have distinct needs. Large enterprises typically require reliable service with service level agreements, such as guaranteed uptime at least 99.99%. And these organizations operate on a massive scale, serving tens of or even hundreds of millions of users, and any downtime or performance issues can have significant business consequences. Thus, reliability, robustness, performance, and privacy are the most important considerations and typically overshadow concerns about cost. Now, in contrast, SMB researchers and community-driven projects often strive for a more delicate balance between cost and service levels. They are often constrained by budget limitations, making them inherently cost-sensitive. Reliable services are important, but they may be willing to make calculated trade-offs between price and service levels to maximize their resources. This flexibility allows them to allocate resources efficiently and prioritize aspects that align with their strategic goals, and the Edge Cloud's flexibility addresses the needs of any type of user, customizing its usage to serve large enterprises, SMBs, and community projects alike. Now, we're also going to be having supported computing tasks with this. The Theta Edge platform is designed to support generic containerized compute tasks as it implements a virtualization layer where users can run any container on the network. The strength of the virtualization layer lies in its capacity to cater to a myriad of computing needs, all with a unified interface that bridges differing requirements, delivering a robust, scalable, and adaptable infrastructure. Now, any computational task can be run on this platform as long as it can be containerized, whether it involves complex data analytics, artificial intelligence, video processing, or even specialized scientific simulations. This flexibility offers a dynamic environment where users can harness the power of containerization and distributed edge and cloud computing resources to optimize, deploy, and scale their workloads with ease and efficiency. Now, computing tasks that can be handled by the Edge Cloud platform include, but not limited to, these followings. We got media and entertainment, as already implemented in the Theta Video API platform. A decentralized edge network platform can handle resource-intensive media and entertainment tasks such as video encoding, live streaming, transcoding, bandwidth sharing efficiently, and the Theta Edge Cloud platform will take this capability to the next level, whether it's encoding video content for multiple formats, transcoding to optimize streaming quality, or rendering complex 3D visual effects for movies and animations. The EdgeCloud platform will provide the scalability and reliability that requires by the largest media companies. Also, artificial intelligence, like we talked about. AI workflow is fairly complex and involves many computational steps that are ideally suited for EdgeCloud's distributed platform. A typical workflow starts with using Jupyter Notebook for the data exploration, where data scientists analyze and pre-process the data sets. The next step involves a hyperparameter turning and neuroarchitecture search, where models are optimized for better performances. Subsequent steps include model training, where the chosen deep learning model learns from the data. If needed, fine-tuning and alignment follow, involving further adjustments and iterations to improve the model's accuracy. And finally, the model is ready for real-world use. It's deployed for serving or interfering. Now, AI interference applications include generative text to image, text to video, large language models, and other custom models. This involves setting up an infrastructure to make predictions accessible to end users or other systems, often through APIs or endpoints. Now, all these tasks from Jupyter Notebook to model serving can easily be containerized, in particular with hyperparameter tuning requires the exploration of multiple combinations and configurations, a computationally intensive process that benefits significantly from the parallelism. Now, these types of tasks are perfectly suited to run on a highly distributed edge network where the ability to distribute these computations across multiple nodes or devices can greatly expedite the optimization process and reduce the time required to find the best model of the hyperparameters. This is also going to help with scientific research. Complex scientific simulation jobs include, for example, weather forecasting, climate monitoring, astrophysics simulations, chemical reactions, molecular structures, and material properties research. These simulations can also analyze large genomic datasets, conduct DNA sequencing, and perform complex bioinformatics tasks for genetics research in the biomedical field. Now, they require massive computational resources to model physical, chemical, and biological phenomena accurately. Using a hybrid of edge and cloud resources, Theta Edge Cloud can direct simulation jobs to the best combination of compute resources to efficiently complete the task. Now we're also going to be having helping with financial modeling. In the financial sector, complex models are often used for risk analysis, high frequency trading, and Monte Carlo simulations to assess investment strategies and market behaviors. These applications play a pivotal role in the industry to analyze and optimize investment strategies, market trends, and risk management. The computational demands of these financial models can be substantial, requiring access to high performance computing resources and capable of handling large-scale data and intricate calculations in real time. The Edge Cloud platform's distributed highly parallel architecture is ideally suited for addressing these types of financial computational needs. Now let's go over the Edge Cloud architecture. To realize the product's vision discussed above, it requires a flexible and scalable hybrid cloud edge computing architecture as shown below. And here it is, the Theta Edge Cloud architecture. You got phase 1, phase 2, and phase 3. Now for the multi-shared architecture. The key design principle is to divide the edge nodes into multiple shards, each type catering to different business requirements. For example, enterprise computation tasks need to run in private and secure environment versus non-sensitive NFTs, media files, and generative AI tasks. This can be executed in a public environment. Other considerations include node reliability, robustness, and performance. Enterprise customers also have more strict SLAs, so those tasks are better run on more reliable nodes. Figure 2 outline the 3 types of shards that are technically there. We got managed shards, data center partner shards, and community shards. Let's go over each one of these. So managed shards are the workers of this type of shards are nodes hosted by Theta Labs in the cloud environment. The worker nodes can communicate directly with each other through a private network, and managed shard is more reliable and ideal for workloads like AI model training, Jupyter Notebook, and tasks with strict SLA requirements from enterprise customers. Then we also have the data center partner shards. These data center workers are nodes run in a partner data center. The worker nodes can communicate directly with each other and can communicate with the master cluster through public IPs, data center shards run by crypto mining businesses, regional cloud service providers, and other partners, also more reliable and equipped with better hardware and software suitable for the workload with certain SLA requirements. Now, we also have community shards. The workers of this type of shards are community nodes running on laptops and desktops, which typically do not have a public IP address. For the worker nodes to communicate directly with each other, a software-defined network that can be configured. This type of shard is typically less performant, reliable, and robust. However, they are optimal for smaller, faster, and highly parallelizable jobs, e.g., like AI hyperparameters tuning, and tasks like AI interface and video encoding with built-in fault-tolerant mechanisms. In the long run, community nodes would also encompass a wide range of devices, including smartphones and smart TVs and distributed IoT devices. Now let's go over the shard management. To effectively coordinate the shards and the worker nodes, a hierarchy work node management approach will be implemented. A coordinated cluster oversees and manages the entire infrastructure for infinite scalability and fault tolerance. It is in charge of intelligently assigning and routing a compute task to the most optimal cluster node. Now, within each shard is a master cluster, manages and orchestrates the shard that instances consisting of an orchestration control plane, providing an API server scheduled and other control components. The master cluster will also implement multiple master nodes to ensure fault tolerance. And then we also have a worker node actually runs the Theta Edge node client software. This will be consistent across all shards except for its hardware specification and performance. For example, in community shards, worker nodes are composed of lower and mid-tier CPUs and GPUs on laptops, PCs, smartphones, and other IoT devices. By contrast, and managed shards initially operate by Theta's worker nodes and will incorporate high-end NVIDIA GPUs such as Tesla's A100s, H100s, and with up to 312 by 624s, FP16 TFL LOPS, and T4s with a 65 FP16 TFL LOPS, and others. Now we have the tasks assigned. Compute tasks are initiated by the EdgeCloud customers and partners through a user-facing dashboard or API for developers. The task metadata is passed to coordinator clusters, which then decide which shard and worker nodes the task should be assigned to. In order to intelligently optimize the distribution of tasks and efficiencies scored will be assigned to each worker node across the EdgeCloud network and a function of various factors. Here's the efficiency underscore score. This is what it is. Given particular computing tasks, the coordinator will compute in real time and route the task to the node and shared with the highest efficiency score, which is this one, the F times job, price, latency, availability. So that's the efficiency score. Now, more advanced technologies like reinforcement learning could also be adopted to determine the task assigned and improve overall system efficiency. Now, we have conducted preliminary research on this technology and published our research finding at the prestigious ACM6. If you want to read it, you can find it there. Now, here's some more diagrams showing the task assignment process of a customer initiation of the computation task. So user admin goes to coordinator, and then goes to the master, and then it goes to the worker, CDN, then back to the coordinated. Now let's go over the token rewards for the Edge node. Now, Edge nodes are rewarded for compute jobs they perform with either T-Fuel or TNT20 tokens issued by Theta partners projects built on Theta's metachain. The coordinator will implement a reward module to calculate jobs reward based on various factors, including but not limited to 1, the job type, 2, correctness of computational results, 3, job completion time, and 4, resource usage of the Edge nodes. To prevent malicious Edge node operators from gaming the system for token rewards, the coordinator will check the correctness of the computational results. Verification of correctness and can be accomplished through the implementations of any of the following approaches. Like 1, the zero-knowledge base correctness checks. Zero-knowledge technology allows the public to check whether a task is completed as prescribed without revealing any specific details about the task itself and without disclosing the actual data of process involved. This is valuable for privacy and security as it ensures that such sensitive information remains confidential while still confirming the accuracy of the work performed. Now, with recent advancements of the ZK snark and ZK ML, these proofs can be made very short and fast to verify. As these technologies mature, a worker client can potentially leverage them to generate success and correctness proofs for the computational jobs assigned and upload the proofs along with the results of the coordinator. Now, the coordinator then verifies the proof and rewards the worker only when the proof is valid, and on this front, Theta Labs collaborate with FedML earlier on related research projects, which resulted in research paper published. Now, there'll also be a way to do this through cross-check. Given the vast parallel computing power of the EdgeCloud platform, it is possible to assign the same jobs to multiple nodes and cross-check the results. And then finally, there's the server-side random verification. The coordinator can also randomly sample a certain percentage of jobs and rerun those jobs on a trust machine by comparing the results, and the coordinator can evaluate whether the result uploaded by a worker node is valid or not. Now let's go over the additional considerations right now, like support for third-party client integration. As an open network, Theta's Edge Cloud platform will support third-party compute clients integration in addition to first-party workers. Currently, the Edge Node software has incorporated a few third-party AI clients, including FedML and Levita, in addition to native video encoding, transcoding, and delivering clients. Now here's a little diagram of the Theta Edge node that supports them. So the first party, the third party is like FedML, Levita client, and we'll probably get some more down the road. Now, FedML is a cloud service for LLMs and generative AI. With the FedML client integration, users can tap into the Theta Edge Cloud through the FedML.ai portal and launch complex model training mobile devices. The FedML client and reward system integrates with Theta Edge nodes was completed in November of 2023, and the Edge nodes are currently compensated with TFR rewards for the FedML AI jobs. Now, Levita AI, the other partner there, is a blockchain AI-based next-generation healthcare platform enabling the use of massive biomedical datasets for research while preserving individual privacy and ownership of data. Through its integration with Theta Edge Cloud, the Levita platform connects individuals with data miners such as pharmaceutical and research companies to participate in new drug trials and treatments, gain insightful genetic information, and latest research findings based on their clinical needs. Now, this was launched in August of 2023, and Theta Edge nodes earn Levita tokens, rewards for the healthcare model. So if you're running an Edge node and you come across a Levita job, you're going to be earning Levita tokens with that. Now, over time, many more third-party clients will be integrated into the Theta Edge Cloud platform and serve as an important building block to improve systems robustness, fault tolerance, and offering alternative ways for users to access the Edge Cloud computational power. As these clients continue to evolve and add more features, they will further enhance the overall functionality and utility of Theta's Edge Cloud. Now we have the distributed storage roadmap and implications. Distributed storage is an integral part of the new Theta Edge Cloud platform. While Theta's Edge Store Alpha release currently offers storage services in the form of a KV store, in the Edge Cloud context, the distributed storage service could take different forms. Below are the different types of use cases for distributed storage in compute-intensive scenarios. We have a temporal storage, a persistent storage, and an immutable storage. So the temporal storage is that this use case requires retaining data in memory or disk for short durations. For example, the training data requires for AI models. This enables quick access to critical information, enhancing the efficiency of compute-intensive jobs, including machine learning and data analysis. Now, persistent storage. The Edge Cloud storage system can be used to host distributed databases, which requires persistent as well as updatable storage. One such type of database that has gained significant traction among the machine learning community in recent years is the so-called vector database. It is the ideal for applications that require fast and accurate similarity search, such as recommendation systems, natural language processing, and computer vision. Vector databases make it easier for machine learning models to retrieve external knowledge based on similar searches. Now, and the final one was immutable storage. Traditional media files include video, VOD, and NFT data files that require immutable storage. Immutability means that once a file or digital content is stored, it cannot be altered, tampered with, or deleted. This is crucial for NFTs and media files because they represent ownership of provenance and unique digital items or content such as digital art collectibles or other virtual assets. Now, in many cases, a worker node will need to access local storage while performing a compute task. In addition, or in the use case listed above, a machine learning algorithm needs to access and load the training data while in process of training a model during model interference, and it might need to query the vector's database for external knowledge. In the case of video transcoding, the original source video file needs to be loaded in order to run transcoding algorithms. Our system design will account for storage resources, utilizing in a temporal, persistent, and immutable mode, while compute rewards will include compensation for the associated storage utilized. Now, what is the product launch strategy? So here we go. Here's some more good juicy news. Theta's EdgeCloud will roll out in three releases to address immediate market opportunities and minimize technical risks while implementing the architecture in Figure 2. So release 1 will be the launch of the cloud-hosted nodes managed by Theta, integrating community token incentives and rewards. This enables Theta to test the fully distributed architectural in a controlled environment and allows for high levels of SLAs for initial enterprise customers. Release 2 will enable partners, including cloud service providers, mining businesses, and community members, to set up and run cloud-hosted nodes in partner data centers. This allows traditional cloud businesses to integrate Theta's EdgeCloud into the existing product offering and providing more cost-effective options for their customers. And then release 3, the raw, fully distributed architecture to Theta's edge nodes run by community working seamlessly with release of 1 and 2 networks, and a coordinated cluster routes any incoming computing task to the most optimal node based on type of job, immediacy, performance, cost, and other services level parameters. Now, the release 1 overview of the cloud-hosted nodes by Theta. Release 1 will enable Elite Edge Nodes operators to participate in Edge Cloud nodes hosted by Theta Labs via a lock and earn mechanism. A new Elite Booster section will be unlocked when that Edge node stakes the full 500,000 T-Fuel through a single non-delegated wallet. This Elite Plus node can then lock additional T-Fuel, separate from the 500,000 for Elite status, and earn boosted T-Fuel rewards for all compute tasks performed in the Edge Cloud, and there is no limit to the additional amount of T-Fuel that can be locked via Elite Plus booster option, and bonus rewards will apply to the longer time locks out there. Now, this is currently scheduled for the summer of 2024 launch, and it's subject to change. Now, the Edge Cloud hosted nodes by Theta will initially include high-end NVIDIA GPUs such as Tesla's A100s, H100s, and with up to 312 by 624s FP16 TFLOPs, the T4s with 65 FP16 TFLOPs, and other high-performance GPUs. These ideally suited for industrial-scale videos, large language models AI, generative AI, and the GPU-intensive computational tasks for the scientific and financial communities, for example. Now, here you can see the jobs completed from text to image, text to video, so it's showing all the different kinds right here, and it's pretty cool right here for the way the new Edge node's looking for Elite Plus Booster, where you get the Google M4. That is just awesome seeing that. But yeah, this is a mock-up of the Elite Edge Node client software with Elite Plus booster options, which will be in the release 1. Now, each Elite Edge node can select their preferred Edge Cloud node to support and can switch to another node at any time on their performance, earnings, and other reasons. Users will have access to an operations dashboard, which is effectively a virtual management window into the node to view jobs completed and the types and the payouts. Now, performance and more. A particular Edge Cloud node can have an N number of Elite Edge nodes supporting it, and all earnings will be shared proportionally among all T-Fuel locked by the N Elite Edge nodes. Now, in the long term, any Elite Edge node supporting a particular Edge Cloud node will have the option to collaborate and vote on various upgrades and enhancements to the underlying cloud node hardware and software specifications, e.g., increasing the VRAM from 8 gigs to 16 gigs, etc. Now, in conclusion, Theta's vision for a decentralized video compute, storage, and delivery edge architecture was introduced in 2021 with the launch of Theta's Edge Network powered by T-Fuel, and further extended with the launch of Theta's Metachain in 2023. That vision is now coming to fruition with over 10,000 monthly active Edge nodes hosted by community members around the world, earning T-Fuel and TNT20 rewards, and over 2.4 billion T-Fuel staked against Elite Edge nodes. Now, building on this solid foundation, the introduction of Theta's next generation generalized EdgeCloud architecture in 2024 to 2025 could fundamentally transform today's centralized cloud service businesses. Now, the immediate strategy is to partner and align with some of the largest cloud providers and become part of their extended architecture, making Theta indispensable to their businesses. This begins with release 1 of cloud hosted nodes managed by Theta and extended edge node clients with an Elite Plus booster option. With the first step, all Elite node operators will be able to partner in the initial development and deployment of Theta's Edge Cloud's distributed architecture, supporting high performance CPUs and GPUs. The release 2 extends this capability for any data center mining operator or community member to deploy these in their own cloud, vastly increasing the capability, robustness, and fault tolerance of the Theta Edge Cloud. And then finally, release of 3 integrates and introduces the world's first hybrid cloud computing platform built on the fully distributed edge architecture. Now, with today's accelerated adoption of decentralized Web3 video, NFT-gated video content with digital rights management, generative AI, and other GPU-intensive applications, this is the perfect time to launch a Theta Edge Cloud and define the future of decentralized computing. So, I know that was long. If you guys bared with me, awesome. But if you want to read this article yourself, links down below. But I am stoked for the future of Theta. Like, this is what we've been building. It's what we've been waiting for. Like, all these patents we keep getting, it's all just slowly coming together. So congrats, Theta, on releasing this white paper. And I cannot wait for those releases. And yeah, so that was that read through for you. So I kind of just really want to get through that before the holidays. Give it a listen to as you drive through to your families tomorrow. And yeah, that's about it. That's all I really wanted to cover. Other news with Theta is, looks like for Theta Drops Marketplace, they've been giving away some VIP shards to the VIP members over there. So you can swap those for merches and goods out there. And Pops and Mags has a new Pinecast out this week. They put another Fresh American Thanksgiving episode of the hit Zilly Awards. So this is also something good to listen to too if you're heading to a Thanksgiving event tomorrow or tonight. But that is it for this Theta Network update. I hope you guys enjoyed it. I know it was long, but if you did and you got something from it, smash that thumbs up, subscribe to the channel, and until next time, the Crypto Sherpa is out.